Hello, everyone. Thank you for joining this session at RSA 2021. I'm Macy Cronkright, Principal Security Architect at Splunk. You can find me on Twitter at Macy Cron. Today, we are discussing what is one of the most exciting industry terms this year, Zero Trust. I'll be sharing how you can start to break down and approach Zero Trust with some practical actions that you can take for implementing Zero Trust in your own remote and hybrid environments, so that you can regain some trust in this changing work environment. So, quick overview, what is Zero Trust? Why are we talking about it now? How do we approach solving this? Some practical things you can apply in your own environment after this talk. Some tips and tricks, and of course, references. And please feel free at any point to ask questions. I'll be joining you live in the chat today, even though I'm joining you via recording right now. At a high level, we're going to start to talk about why Zero Trust is suddenly on our radar now. We'll go into some of the frameworks and ideas that you'll need to approach solving this Zero Trust problem. And we'll look at some of the tips and tricks that I've seen in the field that may be helpful to you. So first off, Zero Trust, what is it? Well, 2020 kind of pushed us further away from the traditional security perimeter, out of our known networks than we'd ever seen before. Most IT organizations were suddenly forced to defend endpoints in new unknown networks. This shift meant that security teams could no longer defend endpoints based on the assumption that they were in known physical networks behind perimeter security, behind physical security, and that even the same subnets or networks applied. So this meant that the security tools need different reference data to identify users and devices. And security frameworks that we had used need their assumptions updated to reassess the risk that we're undertaking now that users are coming in from all different sorts of locations, new devices, new networks. In a nutshell, before the concept of Zero Trust, there were always assumptions made about the status of the network. Users were trusted that when they were in certain networks, they were safe because they were inside a certain physical security zone. For example, joining a corporate building Wi-Fi made assumptions that you were inside the building, at least by proximity. Nowadays, users joining from remote networks, the same assumption can't be made. So we need to take an approach that verifies the user and the device more than once and in more than one way, and every time they try and access a resource on the network. Essentially, what we're trying to do with Zero Trust in a nutshell is prevent lateral movement. So that's a theme we can take through this talk. So again, the endpoints that we're trying to defend have completely moved off of the known map where we were. The security tools like SIEM tools that we often rely on usually have reference data in them that have subnets, networks, users, context about these networks that may not apply anymore. And when we're talking about Zero Trust, we have another mantra here. It's instead of trust but verify, it's never trust, always verify. So we're really flipping around our assumptions here. So where did this come from? John Kindervag, VP and Principal Analyst at Forrester Research, identified this in 2009, and he developed this framework, which identified 6 pillars. People and users. Sometimes we call this identities. A lot of times we call it identities. Devices. Sometimes we call this assets. Networks, which need to be further isolated and segmented than simply trusting anyone on the network because they're on an internal network. We're used to the concept of a DMZ. This is taking the DMZ internal. Everything's a DMZ now. Everything is you versus the outside. So trust or rarely don't trust anything that you're connecting to without going through some sort of zero trust policy that looks at these 6 pillars. So continuing on, we're talking about people and users. Like I said, sometimes they're called identities. They're not always people too. And we'll talk about this in further detail as we get into the talk, but for every human user account, there's probably 3 or 4 machine or tokens or service accounts that are brokering access for that user's activity. So we have to think about more than just the human users, as well as devices. So we often think about devices as perhaps just the endpoint. In our more complex infrastructures, especially with multi-factor, there's perhaps 2 devices in play here, or at least 2 device pathways. So those are sort of foundations, the first 3 pillars. Next, we want to think about workloads, or sometimes what we call applications. And this is where it gets really tricky for Zero Trust. I think this is where we're all comfortable understanding network boundaries, device IP addresses, user account names. But now when we're talking about applications, this is where Zero Trust gets hard, because applications have complex operating boundaries between other network resources. And they, especially complex modern enterprise applications, will more than likely span across multiple vendors, multiple providers, multiple cloud, and different data center backends. And so we can't assume an application is just one thing. It's not Microsoft Excel. I'm thinking payroll. I'm thinking user portal, shopping online. There's lots of different interconnects. And so when we think about an application, perhaps using the word workload expands that. So our thinking is more across complex multi-vendor applications. Hand in hand with workloads is the data that's being consumed by these workloads and applications. So having data policies like encryption will help provide additional protections to this part of the network. Finally, another pillar of Zero Trust, and this is moving away from the observability parts about Zero Trust and more into our response and reaction, is we need tools that can help us do the work of Zero Trust in an automated fashion. There's simply too much in modern applications and modern enterprise design for humans to make these decisions on an ad hoc or queue or ticket-like basis. It just isn't possible, especially since the Pandora's box has already been let out. We are inevitably going to be trying to retrofit the concept of Zero Trust into an already existing mission-critical application. So we're not going to be able to fund or invest in additional human workload to provide the same service just to do better security. So we need a better story there. And to do that, we're going to need tools like automation and orchestration. And it's just this complex nature of modern IT that we're going to need this more sophisticated detection capability through automation, and we're going to need to orchestrate across multiple different platforms, devices, applications, systems, vendors, the results of our policy decisions. So let me just make a tangible example of that. I have a shopping application that crosses across multiple payment vendors. Let's say my app accepts PayPal, Venmo, Bitcoin, and I'm running on Azure, Amazon, and GCP. I have a breach. I have a decision point where my automation has decided that this person or user or device or network is no longer trusted, and I need to make a quick response via automation. So automation works against one application or tool. Orchestration orchestrates across multiple automations across multiple platforms. So that's a little bit of the difference between automation and orchestration. We're going to need both because the nature of modern IT is this multi-cloud, multi-vendor, multi-data center design. So we're going to need multiple tools in our toolkit to achieve this. And without an automated approach to zero trust, there would be no way we could provide the same near real-time experience that our users have come to expect in the application they use today. So that's going to be one of the key capabilities that you're going to need to achieve zero trust. Finally, zero trust is based on information, and it's based on information around the people, devices, networks, and workloads, and how those four things interact with each other. So we're going to need visibility and analytics. One of the key challenges with the implementation and operationalization of a zero trust program will be gaining this needed visibility into key data sources, logs, and events. And where those log sources live, they'll need to be normalized and brought into an analytic capability. So what do I mean by that? We need a way to bring the logs and data and events from various cloud platforms, various applications, custom applications, user traffic, network traffic, and we need to bring them into an analytical platform, which will allow us to do baselining and find anomalies. So, and we'll talk about that more later, how to actually get those analytics and visibility, but you'll need a platform. So these last two pillars that I've been speaking a lot about are really different from the first four pillars. The first four pillars are things that exist today in your network. These are just facts. What we need, the second two pillars, are what we use to analyze those facts and respond to those facts in a zero trust environment. So there are a couple of fundamental assertions in zero trust, and I've tried to synthesize them down to 5. We can assume that the network is always hostile. This is like what I was saying earlier with the DMZ. We used to always think about the DMZ as hostile. Now we have to think about everything outside of our own application as hostile. The device we're on to the network where we inhabit. This means that you cannot allow devices on the same network to freely communicate with each other or use resources on the network because they may have already been compromised. Again, this is as I mentioned earlier, we're trying to prevent lateral movement effectively. So when you make the assumption that the network is not to be trusted, you're going to do certain things, such as encrypt traffic over the wire, have encrypted communications. You're going to have no inherent allow lists that say from this network to this network, just allow this port. You're going to have more fine-grained rules. So we're talking about host-based firewalls. We're talking about encryption. We're talking about setting everything up as an island and its own sort of inhabitant of your DMZ. The network will always have, so the second assertion, the network will always have external and internal threats at all times. So we can assume that there is always a potential for an adverse event, that either through maliciousness, through insider threat, through accidental due to somebody getting compromised from phishing, there's always some kind of threat on the network. And this just supports our assumption that the network is always hostile. So assume that not even that we've made it to an internal network, can we still say that it's safe? We're going to still keep our thought of zero trust prevalent as we keep going through the layers. As I've been saying all along, network locality is not sufficient for deciding trust in the network. As I said in the beginning, 2020 really changed our ideas about where the network boundary really lives. And now it lives in many of our homes and living rooms and coffee shops or home networks. So we can't even make the assumption now that the VPN is safe, that, okay, the user has logged in from the VPN and they're accessing it from within the US, looks good, go ahead and allow that. We have to change our assumptions about that as well. In a zero trust minded approach, we have to strive to ensure that every device, user, and network and the flow of workloads and applications are all authenticated and authorized. So that's a fourth assertion. Every device, user, and network flow with respect to applications and workloads is authenticated. And as I highlighted earlier, these access control policies have to be dynamic, and they have to be calculated with as much information as possible from as many different sources of data as possible. We used to just make blanket assertions. Network A, it trusts network B, trusts network C, et cetera, and leave those rules in place. Instead, the assertion of zero trust is that these fundamental policies are changing all the time. And network A may trust network B in Monday through Friday during working hours for this level of workload. But if there's a sudden, DDoS, denial of service attack, or sudden burst in activity that they're trying to impair, could be hostile, could be accidental, that the policy would gate that away so that the next network would be protected. And so that's how zero trust can help us at all levels, right? Because at its fundamental core, it's allowing a dynamic recalculation of the network rules and policies in place. And that's why, again, we need automation and orchestration informed by the visibility into analytics to really achieve this at a mature level. And as I said, as we employ automation and orchestration techniques, we're going to have a really robust data collection and capture strategy to make sure we have that proper information to make these decisions. So when we we need to think of zero trust as more than just a mindset. It's a mindset that considers every user, device, and workload to be hostile. And even if they are approved and they're a known entity, we continuously reassess their access and authority to the network. And I'll talk a lot about that more, about how we get into the different classifications of user behavior, of asset behavior, and where those analytics need to sit. And again, I think something here that in the 6 pillars isn't called out as much as I would like, and I would like to draw your attention to, is there's also the idea of data sensitivity. So not only do we have applications and workloads, but underpinning that is data as well. And so having a data classification system can also help us here, because ultimately the adversary is looking for one of two things. Either they're looking to use your network as their own resource, so basically a free data center, think botnet, or they're looking for your data, think ransomware. So it's either a targeted attack to get something like your crown jewels, or it's an attack on your infrastructure to just take over your resources and use your compute. Data classification offers us a way to address that second layer, something that's more sensitive to our business. So what are zero trust? The TLDR, the too long didn't read. Don't trust anyone or anything operating inside or outside your network at any time. That goes for people, devices, networks, workloads, applications. And then we're layering in, because all of this is retrofitting into our existing IT environments, is automation and orchestration. So basically, I'm in your computer stealing your data. This little kitty, it probably has the same user profile, doesn't have the same typing activity, doesn't have the same browsing history, doesn't have the same workload, or is going after the same resources that a normal user would. So just kind of as a funny to think about, how are we going to see these things, and don't trust anyone inside or outside of the network. So that was a lot about what zero trust is. So why now? So why are we seeing zero trust as a thing? We're seeing these trends across IT and security. First was the move from the static perimeter-based policies. In a legacy view, we're thinking that a computer is a workstation that sits at a desk at an office at a certain floor of the building. Now users are flipped completely the other way to remote. So that static boundary is almost meaningless now. So any rules that we had have to change and evolve around that. So legacy was protecting the physical perimeter. Now we have to think about protecting assets, users, and resources, no matter where they exist physically. So our assets may be computers, laptops, bring your own device, mobiles. It might be users who are outside of the country, outside of the office, maybe at a coffee shop, maybe at a home network that is not secure. Something I think we may not have always thought about is that in our new work life after the pandemic, we're seeing that users are sharing networks. You have homes where there are multiple IT users who are accessing multiple critical networks from the same location. So what does that mean for file sharing? What does that mean if your laptop is inadvertently sharing documents, et cetera? We have to think about some different ways overlap can start to happen. So the modern way of thinking about this, the more zero trust way, is protecting assets, users, and resources, not just this perimeter. The trend of implicitly trusting the perimeter was already a weak solution, and we'd seen that before. Every ransomware attack that we've seen has happened because once it gains a foothold, it has unfettered access to every other device on the same trusted network. So zero trust is something that can really help us with the ransomware or the malware threat. Continuing on that theme of isolation and segmentation of networks, we're seeing the trend move from an approach where we needed approval to connect to the network. And now we're moving to a trend where we want to see the approval when we connect to each resource. So an example of that is when I would go to the physical office, I would join the corporate Wi-Fi. And once I was at the corporate Wi-Fi, I had unfettered access to all the other applications. It was as if I was plugged in to the network cord at my desk. So instead, we need to think about this a little bit more robustly. What if I wasn't me and my laptop was outside the building or was compromised? So we need to think about how each time I ask for a different network resource, re-authenticating and rechecking the context of my user and my device and the resource request I'm asking for. Is it within my normal operating behavior? Instead of just approving everything just because I'm either A, on the VPN, or B, on the corporate Wi-Fi or connected physically. So what we're going to start to see, this is what's called comply to connect to each resource. That my device, my user, my profile, my behavior is all complied before I can connect to a resource, not the opposite. These approvals and authentications, again, need to happen relatively seamlessly to give a good user experience, to have a successful user experience. Otherwise, as you know, once the C-level is can't do it, then it's going to be very hard for our users to do the same. So we want to see automation and orchestration help with these tools. We often see this feature exhibited. You've probably seen this in your own networks, when you've had to re-authenticate every few minutes. It kind of gets silly after a while. So we have to think about how do we make our user experience better there. Finally, we're also seeing this move towards zero trust because the older IT infrastructures were very siloed by product or tools, but now we're seeing a lot of integration between tools and product stacks and a whole of agency approach. So, this is very much like our multi-cloud designs that we're starting to see now, where different tool sets are interchangeable. So we've got to see a whole of organization or agency approach to how we roll this out. More factors that are driving zero trust. Despite the changes in industry where it's been seen over time, 2020 really just pushed us forward. The rapid erosion of the network boundary was almost overnight when the lockdowns began. The shift to remote work meant a lot of policies, network policies, had to be flipped. So now more than ever, and no time too early to recheck how those policies may be have changed our security posture given this dynamic shift. And it's really just brought to light how devices and users are used in remote workforce. That iPad that was sitting, that perhaps a child was using for homework before may also be used for work an hour later. So we have to really rethink what is on the device and other users who may be on the device, especially in BYOD. Visibility and analytics. And if you remember this year where the meme was, I am not a cat, lawyer cat came online. It's just another example of zero trust. Finding out who is on the other side of the Zoom is very much a zero trust problem. The cat had the filter and the lawyer was like, I am not a cat. This is about access and authentication. This is how do we know that it really wasn't a hacker kitty on the other side? We would need context, right? And as Lawyer Kitty explained on the Zoom call, he had other ways to prove that he was human. So just another funny way to think about it. But, we really have to really start to say there is no such thing as a trusted user. Anyone could be a cat on the internet. So we're finally seeing how much visibility and analytics we need to really start to leverage here for zero trust. So let me take you through a very common cyber scenario. This is the remote exploit or insider threat. In this situation, a malicious cyber actor compromises a user device, either through an internet-based mobile code exploit, or the actor is an inside authorized user with malicious intentions. And this scenario is pretty much the most common, classical cybersecurity scenario we can have. We don't know if a user's credentials have been exploited because they've been discovered, or the user has turned bad and malicious. So we don't know, right? And that's, again, a perfect situation for zero trust. So in this non-zero trust scenario, the actor gets the user's credentials, enumerates the network, and laterally moves because the user could, giving the malicious actor access to data and also persistence. Once the user's credentials have been compromised, most of the network has been compromised as well. That's why spear phishing remains one of the most sought after trainings in cybersecurity, because once we lose that user credential, so much of the network could potentially be compromised. In a zero trust network, however, the network is segmented, limiting both enumeration and lateral movement opportunities. And the reason the network is segmented is the compromised user credentials and the device are already assumed to be malicious until proven otherwise. So at every step of the way, at every resource request, at every network traversal, these questions about the context of the user and the device are asked again and again and rechecked. And because this situation is so common, we can also, that's why we can reference this idea that assume that the user and the device is already compromised. Another scenario that we're seeing as an emerging threat is the supply chain compromise. In this scenario, a malicious actor embeds malicious code into a popular enterprise network device or application. The device or application is maintained and regularly updated according to the organization's best practices, which is correct because we want to make sure we have the most secure and up-to-date software. In a traditional network architecture, this device or application would be internal and fully trusted. Now, this type of compromise can be particularly severe, as we saw this year, because it's so implicitly trusted. In a mature implementation of zero trust, however, we would have had to flip the script and behave as though that software was not inherently trusted. Its privileges and accesses to data would have been tightly controlled, minimized, and monitored. Segmentation macro at the network boundary when the download occurred, and micro between the network segments or between the services on the operating system, so that the executable couldn't then pivot and start to read data off the operating system. So micro segmentation down to what I was saying earlier, data on the device. And then, analyzing supply chain is going to be a hard problem, but it becomes easier when you have visibility and analytics over many years. So if you can look at the trends of perhaps, your favorite monitoring tool or whatever trusted application, and you look for patterns, are they updating at the same time of year? Is this code update authorized, mentioned, blogged about, MD5, et cetera? You can look and see if the file size was the same. Was it produced by the same certificate publisher, root cert, et cetera? So, at the end of the day, there's a popular game called Among Us, and its premise is that there is one hacker among us, someone that is not to be trusted. And that's basically the premise of zero trust, that assume there's already someone kind of sus or suspicious among us. So I'm going to talk now about some practical approaches. Zero trust is not a product, a solution that you can buy. Rather, it is a methodology that requires the organization to rethink their security strategy and architecture. It's a methodology. Again, it's a mindset. It's a flipping of the script of what our assumptions used to be. It's going to require a collection of products and services across vendors to work together. And something I would like you to take away is that there is no partial trust. Abandon the idea because that would just negate all of your efforts. Think service-oriented architectures from the 2000s. Some challenges that we'll see implementing this is a lack of full support. Administrators and defenders are going to get fatigued with the idea of constantly having to defend against this unknown threat. So you'll need to create scalable, automated, repeatable, bite-sized processes so that this fatigue doesn't pervade through the entire organization, from leadership through your administrators. It will get exhausting as you transform. Here's an algorithm I like to keep in the back of my mind about what are all these 6 pillars and how to bring it all together. The identity trust equals the identity access granting account, the API, the user, the service, whatever, plus the device requesting access and its location, cloud, on-premise, remote. Those 3 things create a context, and that context includes time, date, season, perhaps, asset type, identity type, resource, application. Is it normal, anomalous? Which will create ongoing intelligence that you can store and drive those continuously improving policies, those dynamically changing policies. So it's a bit of a multivariate function. It does feed itself, it does grow itself, but that's why you will need more advanced capabilities. I'm going to say there's some practical approaches here. I talked about one before, which is comply to connect. That's a notion that who and what is connecting to my network. They have to be healthy. They have to have certain criteria met before I deem them worthy or acceptable on the network. Use continuous CDM or continuous diagnostic monitoring. Now that the user is connected, what are they doing? Look and watch and log the user behaviors so that you can look for anomalous activity later. And then my favorite, most important thing I want to tell you is develop an anomaly detection capability. This is really the power that will feed your zero trust policy engine. You need a place to store long-term log data, metadata, like time, location, IP address, username, email. And you need a way to run analytics by time, user, device across multiple years, because you'll want to catch seasonality. And you'll need a way to compile user and device profiles. And these profiles should baseline some things about your devices and users, like installed applications over time, the files they have, where have they been over time, what are their MAC addresses. This way you're able to detect variations, anomalies, deviations. So record the norm so you can detect the abnormal. Users will have locations, common devices, they'll have common resources accessed, common systems, and paths. You can baseline all those with metadata. Define your outcome from the start. Find out what your critical data assets, applications, and services are. Start protecting that asset and work your way out. Secure all the pathways of network access to get in. Determine who, again, what are the users that need that access. Inspect and log all traffic before acting. Again, this goes back to our visibility and analytics need inside the last pillar of Zero Trust. And now I'm going to just talk a little bit about some wrong assumptions people make, or some wrong ways I found that people go about this. One is just choosing the most critical application as the proving ground and going with that. There's a bunch of reasons why that's flawed, but the most important is that if it is your most important mission critical application, it's going to be the hardest to define changes on that are not risky. Pulling the trigger on a boundary change, on blocking access, is a service interrupting event. It can be, and guaranteeing that is very hard. So you want to choose something else. Don't choose the most important, most critical asset first. Choose something smaller so you can practice and gain those skills. Another mistake people make is focusing on all the identities. Instead, I would suggest focus on the human users first, then look for the machine mapping. So, because with human users, you can start to baseline and build contacts and activities. The third thing I see is allow any device access to any application. Sometimes people get confused about Zero Trust and how it relates to remote work and mobile devices and think like, oh, now that we have multi-factor, all our mobile devices can access anything we need and we've got it. Again, that will just open the door to reversing the script and having everything wide open. So again, you want to start somewhere small so you can get some wins and map out all the paths in and out. Another approach people take is say, oh, I'll just forget it. This is all so complicated. I'll just take my existing system and move it to the cloud because the cloud has various tools already built in for Zero Trust. Unfortunately, that's probably a risky move because without knowing all the ins and outs of an application, when you move it to the cloud, you may inadvertently expose yourself across the internet. You just don't know unless you've got that complete visibility. So finally, quick things to apply. Applying in practice, this is what you can take to your office today. Look for user accounts that have multi-factor token that have a common key, like an employee ID. Make sure that that common key is across all your access control systems. Make sure you've got real-time log monitoring available for the devices in the network, and find out how you're applying microsegmentation today. You can also implement file-level access monitoring, so at least you get visibility into who is accessing what at that data layer. Start to use ML and SOAR. SOAR is automated orchestration and response to complement your security event management tools. You got to baseline good so that you can act on bad. Find the logging gaps, look for an executive sponsor, and like I keep saying, start baselining your users. So in the next couple of weeks, I challenge you to go look for those logging gaps, start the conversation with your leadership, look at, in the next few months, look at how microsegmentation can be applied for your networks and devices, gather any missing data, start to understand your user activity by tracing fully, and look for an executive sponsor. And then as you gain your executive sponsor, start to baseline your user activity. At the end of the day, applying Zero Trust in real life is don't trust me, don't trust anything you hear. Just kidding. I hope this helped. I would like to share with you some references here. Embracing Zero Trust. I will give you these links at the end of the talk. Looking forward to your questions on how we can implement Zero Trust in our networks. Thanks again. And my name is Macy Cronkright.